Hi everyone, my name is Zach, and in this chapter we will take a look at procedural shading and how we can render our scene. In this and the following videos I show you how to easily add materials to your objects with mainly procedural textures, but also with seamless textures and some other nice shading workflows. So what does this whole procedural thing mean? Our dynamic topology sculpting now has a very bad topology and a lot of polygons, and in order to create proper UV maps, textures and so on, we have to create a retopology object, and this is pretty time consuming. And if you just want to create a quick nice rendering of your pure dynamic topology sculpting, procedural shading is really useful. Procedural textures are basically textures which are generated through a certain algorithm. That means there is no image texture lying somewhere, it's just generated on the fly from Blender. So, and the nice thing is that procedural textures are really flexible. We can change values to change the appearance of the textures. And the best thing of procedural textures is that we can project them onto our model without visible seams. And that's because procedural textures are in actual fact 3D textures. So imagine your object stands inside a cloud or something like this, and everywhere where the cloud is touching the surface, there the texture will be projected onto the object. And in this way no seams will be visible. So in this first video we take a look at the principal shader, which is a kind of Uber shader, which helps us to create basically any kind of material. This we need as foundation to later on use procedural textures and seamless textures to create our final material. So, without further words, let's get started. Okay, here as example I use my Sphinx cat, and as you can see I have 3 area lights in my scene. With numpad 0 down here I can switch into my camera view. I've splitted my 3D viewport here. I've switched to the cycles render engine. And over here we have the node editor enabled, as you can see here. And I assume that you already know how to use the nodes in Blender cycles and how the material works in general. So I don't want to do a beginner tutorial here about shading. I just want to concentrate on the procedural shading methods we have here in Blender. So down here I hit Shift Z, render the viewport. And up here I select the Sphinx cat. Now over in the node editor, make sure that the shader nodes are enabled, and then I hit new and rename this shader into test. As standard nodes we have the diffuse shader and the material output node. The material output node is important so that we can see the material on the surface of our object. So if I change the color here, you can see how this is changing. But if I unplug this, you can see this is just black. So it's important that this here is connected at the end. So Blender offers a lot of different shaders. With Shift A shader I can add such shader nodes like the glossy shader. Now you can see we have this glossy surface, or we have the glass shader, which is basically a transparent shader with refraction and stuff like this. But luckily, since Blender 2.79, we have a new shader called Principal BSDF. And as you can see, this thing has a lot of settings, but don't be afraid. In most cases, we just need a very few of them. And the cool thing is that this shader is physical based. That means it calculates some things in a certain way that it looks most realistic. And usually we have to build this PBR, physical based rendering stuff on our own, but now Blender does this with this kind of Uber shader. That means in most cases we only need this shader here to create nearly all of our materials. So here I just want to go through some of the values which we will use a lot, because some of the things here are for very special things, and in most cases you just need the sliders, which I will show you here. So first of all, let's talk about materials which are not metallic and also have no transparency in it, like glass, water or something like this. So the first thing we have here is the base color. This defines the basic color of our object, as you can see. Then we have the specular value, which basically defines how strong the specularity should be, the glossiness. As you can see, if I put this down to 0, we have no reflection, and if I put this up to 1, we have a lot of reflection. The standard value of 0.5 is in most cases fine. Then another very important slider is the roughness slider. This defines how soft or sharp the reflection should be. So if I put this down to 0, you can see we have a very sharp reflection here. And if I slowly increase this, you can see how this reflection will be softened, as if the surface is rough. Then we have this subsurface slider, which basically mixes our base color with subsurface scattering. So let's put this up to 1. And here you can now see what subsurface scattering is. It means that the light from the back side is shining through on the front side. You know this effect if you're standing in front of a lamp and through the thin areas of your ear you can see the light shining through. And with this effect you can do things like skin, wax, milk, something like this. Now we have a few additional options here. For example, the subsurf color, which defines the color of the light which is shining through, as you can see. We can mix this with our yellow color up here. Now you can see the light which is shining through is blue, but our base color is yellow. And then we have the radius here, which basically defines how deep the light rays are coming through the object. So if I put this down, for example, to 0.1, you can see the effect is much weaker. And why do we have 3 values? This is basically R, G, and B, red, green, and blue. And in this way we can define that, for example, the red values will shine deeper than the blue or the green values. So let's set this back to orange, for example. And here let's, for example, put down green and blue to 0, and you can see now only red is shining through. If I increase, for example, the green one, you can see it looks green. And if I put the blue one up, you can see we have this blue shining through. So in this way you can control which color is shining through more. Like on skin, there is, for example, the red color shining more through than blue and green. But it depends on what you want to create. So let's put this down. So now let's quickly take a look at metallic materials. It's pretty easy in actual fact. We have this metallic slider, and with this slider we can define should this material be metallic or not. So 0 means not and 1 means this is metal. And as you can see, now this looks like a metal cat. Let's tint this a little bit more orange and then it looks a little bit like gold. And also here the roughness is important because the roughness defines if this should be this very shiny metal or this more rough metal. So let's put this down to 0. Now we have a non-metal material again. And the last quick thing I want to show you is down here, transmission. If I put this value up, we have this transparent material. The base color also is important here. So if I put this back to white, you can see it's now like soft glass because the roughness value again is important. And we have this IOR value, which basically defines how strong the refraction should be. This IOR stands for index of refraction. So if I put this down to 1, you can see we have no refraction. And if I slowly increase this, we will have this refraction. Yeah, and you don't need to guess what IOR you need. There are lists online, just Google IOR list, for example, and then you find lists for the IORs of different materials like glass, water, and so on. And all the other things like sheen, clear coat, anisotropic, these are stuff for special things, and I don't want to talk about that in this video because we will not use this here. So this is a basic about the principal shader, and this we will use as basis for everything we create, because we need a shader as basis and then we can plug in textures which will define the finer structures on the surface.